All right, welcome back, North Beach physical science students. I hope you guys are all doing well, and thanks to those that have connected with me online through text messages as well, phone calls, seeing you guys around town. Nice to see you guys. So hope you guys are all doing well and working on the assignment. I'm going to start off today with just doing a little bit of review on potential energy before we go into kinetic energy and how we solve some of those problems. So, excuse me, without further ado, remember, potential energy is all about position of an object, in this case, since we're talking about physical science. So we're talking about a gigantic boulder on the top of a hill, a car that's on an on-ramp, you standing on top of a tightrope above a cliff for some reason. It's all about mass, gravity, and height, and that relationship together. And we'll remember that what we're working with in this case is answering our answer in energy, which is joules. So potential energy again, so P of E is equal to mass times gravity times height. And some of you guys asked if mass is in pounds. No, in this case it's in kilograms, because mass is fundamental. It doesn't change. Weight changes due to gravitational influence. So depending on where you're at within the universe, your weight will change. But in this case, we're going to stick with Earth's gravitational attraction at 9.8 meters per second. And height is going to be in meters, always, not in feet, okay? So that is our equation. And if we're going forward and we're just solving for potential energy, we're taking mass times gravity times height, and our answer is going to be in joules, big ol' J, okay? So the first problems I'm going to do are straightforward, and then we're going to look at some of which we have to solve for an unknown, as well as can potential energy be equal between individuals if they have different amount of mass, okay? So the first one I've got for you guys is I've got mass of an object is equal to 150 kilograms. I know that gravity, so G is going to equal to 9.8. And my height says I'm 5 meters above the ground. So in this case, I'm just going to plug it in my calculator with my parentheses to make life really easy. So if I did that in my calculator, it would be 150 times 9.8 times 5. And if I solve for this correctly, my answer would be 7,350 joules, just like that. So that was the first one, right? So 155 and 9.8, perfect. Now, at the same time, let's go with one that we don't know, we have an unknown. So let's say we know our potential energy. So our P of E is equal to 3,160.5 joules. We know the mass is equal to 43 kilograms. We know G is going to equal to 9.8, but we don't know our height. Okay, so this is what we're going to solve for. So I'm going to set my problem. I'm going to isolate my 3,160.5 joules is equal to 43 times 9.8 times x. Just like so. So next, I'm going to take 43 times 9.8, and this will give me 421.4 times x is still equal to 3,160.5 joules. Now to solve for x, we're going to divide 421 by itself. So we're going to get rid of this. And we're going to divide on this side 421.4. If I do that, I take 3,160.5 divided by 421.4, x will tell me that that object is 7.5 meters above the Earth. So that's how you would solve for an unknown. Now, sometimes people ask within physical science and in physics, can you have two objects that have the same amount of potential energy in a system, so they're equal, but their masses or their height, or even sometimes their gravitational attraction can be different? And that's true. So I'm going to show you a scenario of my daughter and I, since she's, if you guys don't know Lily yet, she's a little rambunctious kiddo. She's a lot of fun, but she also doesn't have a whole lot of fear, which is good and bad at the same time. So we're going to do a gravitational potential energy problem, or potential energy problem of us deciding that we're going to jump into a gigantic pool of water. So let's imagine that we're at a Olympic stadium. We have a gigantic high dive, and I want to jump from about the 10-foot position. So remember, we're using meters, so I'm going to make this into 3 meters. So I've got me, and so my mass is 111.36 kilograms. So I'm not using pounds, so my mass, so let's do this, so mass is equal to 111.36 kilograms. I know gravity is going to equal 9.8, and I'm going to jump from a height of 3 meters. So a fairly large jump, 10 feet or so. So I'm going to multiply these together. So I've got 111.36 times 9.8 times 3. And I would end up with 3,273.98 joules. So that's how much energy I would have if I jumped from a 3 meter high dive platform in an Olympic pool. So let's say my daughter, though, wants to copy me, since she's kind of copycat. So she wants to have the same amount of energy. So she's like, Dad, I'm somehow at 5 years old, I know calculations of physical science and physics, so I'm going to do this. So Lily has a potential energy that's equal to mine. So she's got 3,273.98 joules. And, I mean, as you could guess, my daughter is much smaller than me, so her mass is only 20.45 kilograms. G is going to equal 9.8, but height, we don't know. We're solving for height. So, like before, we're going to isolate our problem, so I got 3,273.98 joules is equal to her 20.45 mass times gravity times height. So remember, x is height, that's what we're solving for. So I'm going to take my 20.45, multiply it by my 9.8, and I'll get 200.41 times x still is equal to 3,273.98 joules. So just like we did on the last problem before I erased everything. So I'm going to divide by 200.41. I'm going to divide this side by 200.41. So I'm solving for x. In this case, x would be 16.33 meters. So if my daughter wanted to have the same amount of energy as me, she would have to jump from a height of almost 5 times taller than I started with. So her height would be at 16.33 meters, while mine's at 3 meters, for us to have the same amount of potential energy, 3,273.98 joules. So yes, you can have the same amount of potential energy. You just have to either change your mass or your height. So this is a huge balancing game sometimes within solving these problems. Please reach out for help if you guys are struggling still on the potential energy problems. We're going to move next into kinetic energy problems, and I'm going to solve some of those straightforward as well as unknown. So I hope you guys are well, and I'll talk to you all soon. Peace.